morning, students. Welcome to the third session of sequences and series. In the last class, we started off with the arithmetic progression or AP, and I also told you about what arithmetic mean is, and we solved one problem based on inserting certain number of or n number of arithmetic mean in between two given numbers. In this class, we will continue with more problems on AP or arithmetic mean. Write down the problem. Find the sum of odd integers. Find the sum of odd integers from 1 to 2001. Find the sum of odd integers from 1 to 2001. So look at the question there. We have to find out the sum of the odd integers from 1 up to 2001. So which are the odd integers from 1 up to 2001? The first odd integer is 1, right? Then comes 3, then comes 5, okay? So on. So the numbers, odd integers from 1 to 2001 are 1, 3, 5. It goes on like this, okay? Which is the last odd integer up to 2001? 2001 is the last odd integer, correct? So the one odd integer, one before that, the odd integer before 2001 will be 1999. So the one before the last is 1999 and the last is 2001. So these are the odd integers from 1 to 2001. So there are many number of odd integers in between 5 and 1999. Now look at the sequence of numbers. We have 1, 3, 5, so on, 1999, 2001. What kind of a sequence is this? Obviously, when you observe, this is an AP. Why? Because there is a common difference between the consecutive terms. Second term minus first term. 3 minus 1 gives us 2. Then third term minus second term. 5 minus 5 minus 3. It is giving us 2 again. So you can see that there is a common difference between the consecutive terms of this sequence of numbers. Hence this is an example for an AP. Now what kind of AP is this? This is an AP with first term. What is the first term of this AP? It is 1. So I will write A equals 1. First term A is equal to 1. What is the common difference? It is 2. So I will write small letter d equals 2. So this is an AP with first term 1. We have denoted it by small a. Common difference 2. We have denoted that by small d. Now, what is the question asking us to do? We need to find out the sum of the terms of this AP, right? So to find out sum of terms of the AP, what formula are we going to use? We are going to use the formula Sn. Sn is nothing but sum of first n terms of an AP. So what is the formula for sum of first n terms of an AP? Sn equals n by 2 into 2a plus n minus 1 into d. This is the formula for sum of first n terms of an AP. N by 2 into 2a plus n minus 1 into d. Now look here, what are the terms required here? We want the first term A, then we want the common difference D, also we need the value of small n, right? We know the value of A to be 1, value of D we know it to be 2. We have to first and foremost find out value of n. Value of n is nothing but the number of terms in this AP. So the last term we know it to be 2001. We have to find out the position of 2001 in this particular AP. If we can find out the position, or in other words, which term is 2001 of this AP. If we can find that out, then that will be nothing but value of n. Once we find out value of n, we substitute values of A, D and n here and we calculate Sn. Okay. Now, how do we find out the position of 2001? In other words, the value of n. Well, it is very simple. We have to equate 2001 to the general term of an AP. An, or the nth term, right? Nth term of an AP is what? In the previous class we discussed that general term or nth term of an AP while I did general form of an AP, right? If A and D are the first term and common difference of an AP, then the general form will be A, comma A plus D, comma A plus 2D, comma so on, comma A plus n minus 1 into D. So A plus n minus 1 into D, A plus n minus 1 into D is what? The general term of this an AP. Okay. Now we are going to just equate this general term to 2001. Find out the value of n. Okay. A plus n minus 1 into D equals 2001. Okay. So what happens? So we take let A plus n minus 1 into D equals 2001. What is value of A? Value of A is 1. N minus 1, value of D is 2, equals 2001. So we have to simplify this equation and find out the value of n. So we do that now. 1 plus, I can write this as 2n minus 2 equals 2001. You people can pause the video and you continue to find out the value of n and then play it again and see whether you're getting the same value. Okay. Now the next step, 2n minus 2 plus 1 gives us minus 1 equals 2001. So taking minus 1 that side, what do we get? 2n as it is, 2n equals minus 1 becomes plus 1. So plus 1 plus 2001 is 2002. Okay. What is value of n? N is 2002 by 2. You get 1001. So the value of n, we are getting it to be 1001. So what is the meaning of that? 2001 is the 1001 term of this particular AP. Now that we have got all three values, A value, D value as well as N value, we will substitute all those three here and then find out the sum of 1001 term of this AP. Okay, so what is S1001 equal to? 1001 by 2. I am using this formula. In the place of N I have substituted 1001. In the place of A we are going to substitute 1. In the place of D we are going to substitute 2. So this is 2 into A, 2 into 1 plus N minus 1, 1001 minus 1 into D. D value is 2. Okay, so on further simplification, again you can pause the video, simplify and play it again and see whether you are getting the same answer. I encourage you to do that on every working problems. Okay, whenever we are working out problems, whenever we are simplifying, you pause the video and try to simplify on your own, and then you try to play it and see whether you're getting the same answer or not. Okay. Nevertheless, we'll solve this. 1001 by 2 into, what do we get? 2 plus 1001 minus 1 is 1000 into 2. Okay. I can write this as 1001 by 2 into 1000 into 2 is 2000. 2000 plus 2 is 2002. Okay. 2 ones are, I'll simplify this, 1001. 2 ones are 2001. Okay, so what is 1001 into 1001? 1001 into 1001 we have. This is 1001. Then 4 more zeros I have to put. Then 2 zeros. Then 4 more zeros I have to put. Then 3 zeros. Then 1001. Okay, so this is 1 0 0 2 0 0 1. So we get 100 2001. Okay, so this is the sum of the first of all the odd numbers between 1 up to 2001. Moving on to the next problem, problem number 2. Write on the problem, find the sum of all natural numbers. Find the sum of all natural numbers lying between 100 and 1000, lying between 100 and 1000, which are multiples of 5, which are multiples of 5. I repeat the question once again. Find the sum of all natural numbers lying between 100 and 1000, which are multiples of 5. Okay, look here. What is given in the question? We have to find out the sum of all natural numbers lying between 100 and 1000, which are multiples of 5. Okay. Now, we have to think about the natural numbers lying between 100 and 1000, which are multiples of 5. So, which is the first natural number which is a multiple of 5 and which is lying between 100 and 1000? Correct. It is 105, right? 105 is the first natural number lying between 100 and 1000, and it is also a multiple of 5. Then, which is the second natural number? After 105, we have 110. After 110, we have 115, comma, so on. Which is the last number which is a multiple of 5 and lying between 100 and 1000? Correct. It is 995. One before 995, one number which is a multiple of 5 and before 995 is 990. So we'll write that also, 990, comma 995. So we have written the numbers lying between 100 and 1000, which are multiples of 5. Which are they? 105, 110, 115, so on, 990, 995. Okay. Now look at the sequence of numbers. Again, the sequence of numbers is an AP with first term. What is the first term of this AP? A equals 105, correct. What is the common difference? Second term minus first term. 110 minus 105 is 5. Third term minus second term. 115 minus 110 is 5 again. So common difference D equals 5. Now what is the question asking us to do? We have to find the sum of all the terms of this particular AP. Again, just like the previous problem, we have to find out Sn. Sn formula is Sn equals n by 2 into 2a plus n minus 1 into d. Again, we have to find out the value of n. So which is the last term here? It is 995. We have to find out the position of 995 in this particular AP. What do? We equate 995 to the general term of this AP, a plus n minus 1 into d. We'll do that and find out value of n. A plus n minus 1 into d equals 995. What is value of A? Value of A is 105 plus n minus 1 into d. D is 5 equals 995. Okay. Moving on further, I can simplify this as 105 plus 5n minus 5 equals 995. Okay. Now I can write this as 5n. 105 minus 5 is 100 plus 100 equals 995. Okay. Taking 100 to the RHS, 5n equals 995 minus 100 is 895. 895. What's value of n? 895 by 5. 5 ones are 5. So how much do you get? 39. 5 sevens are 35. 4 is remaining. 5 nines are 45. So value of n equals 179. Now we have the values of A, D. We also calculated value of n. All we have to do is use Sn formula and find out the sum to 179 terms of this particular AP. That will be the sum of numbers which are multiples of 5 lying between 100 and 1000. Okay, so S179 equals n by 2 is 179 by 2 into 2a. 2 into a is 2 into 105 plus n minus 1. 179 minus 1 into d. D value is 5. Okay, we'll simplify this. So what do we get? 179 by 2 into 105 into 2. 2 5s are 10. 2 1s are 2. 210 minus 179 minus 1 is 178 into 5. We'll find out 178 into 5. 178 into 5 gives us 8 5s are 40. 7 5s are 35, 39. 5 1s are 5 plus 3, 8. So this is 890. So what do we get? 179 by 2 into 210 plus 890. So 890 plus 210. 890 plus 210 gives us 1100. Okay, so I can write this as 179 by 2 into 1100. Okay, I will simplify these two. 2 ones are, 2 5s are 10, 2 5s are 10, 2 zeros are 0. So 179 into 550. We'll do it now. 179 into 550 gives us 0, 0, 0. So 1 0, 5 9s are 45, 5 7s are 35, 39, 5 1s are 5, 3, 8. We'll put 2 more zeros. 5 9s are 45, 5 7s are 35, 39, 5 3s are 5 1s are 5 plus 3, 8. Okay. So what do we get? 9 plus 5 gives us 14. So this is 18. So we get it as 98,450. So the sum of the natural numbers lying between 100 and 1000, which are multiples of 5, is 98,450. Okay, moving on, write down the third problem. In an AP, the first term is 2. In an AP, the first term is 2, and the sum of first 5 terms is 1/4, and the sum of first 5 terms is 1/4 of the next 5 terms, is 1/4 of the next 5 terms. Full stop. Next sentence. Show that 20th term is minus 112. Show that the 20th term is minus 112. I repeat the question once again. In an AP, first term is 2, and the sum of first 5 terms is 1/4 of next 5 terms. Full stop. Next sentence. Show that 20th term is minus 112. Okay, now look here. What is the question asking us to do? It is saying the first term is 2. It is given that first term is 2. We know that first term we denote it by small letter a. So I have written a equals 2. Then what else is given there? Sum of first 5 terms is 1/4 of next 5 terms. Now how can we write sum of first 5 terms of an AP? I can denote it by S5. S5 is sum of first 5 terms of an AP. Okay, how can I denote the next 5 terms of an AP? S5 is nothing but A plus A2 plus A3 plus A4 plus A5, right? S5 is nothing but sum of first 5 terms, A plus A2 plus A3 plus A4 plus A5. What is sum of next 5 terms? Okay, sum of next 5 terms is A6 plus A7 plus A8 plus A9 plus A10, right? So this is sum of next 5 terms. I have to write sum of next 5 terms in terms of S5 or in terms of sum of n terms. Okay, so how can I write that? What is S10? S10 is what? S10 is A plus A2 plus so on up to A10, right? So S10 is sum of first n terms of AP. Now, sum of first 5 terms of AP, we have written it as S5, right? A plus A2 plus A3 plus A4 plus A5. But what do we require? We require sum of next 5 terms. A6 plus A7 up to plus A10. Now, can I write this as S10 minus S5? Yes. What is S10? S10 is A plus A2 plus so on up to plus A10. S10 minus S5. I am subtracting the first 5 terms from sum of the first n terms, right? So I delete the first 5 terms. If I subtract the first 5 terms, what am I left with? They are nothing but the next 5 terms, A6 plus A7 plus A8 plus so on up to plus A10. Okay, so the next 5 terms I can denote it by S10 minus S5. The first 5 terms I denote it by S5. But what is given in the question? Sum of first 5 terms is 1/4 of next 5 terms. First 5 terms is S5. Next sum of next 5 terms is S10 minus S5. So I can write sum of first 5 terms is 1/4 the next 5 terms. It is nothing but S5 equals 1/4 into S10 minus S5. So this is the second information given in the problem. What must we show? We have to show that 20th term, that is A20 equals minus 112. We have to show that the 20th term is minus 112. So to show that 20th term is minus 112, we need to know the value of A, D and 20. 20 is already given there. Okay, we have to know the value of A and D. A value is already given in the problem. So using this information, okay, S5 equals 1/4 into S10 minus S5, we will try to find out the value of D. Okay. So we'll use this. S5 equals 1/4 into S10. Okay, from this information we will try to find out value of D. We already have the value of A. All we have to find out is value of D. Substitute both values of A and D in A20 term and then find out, prove that 28th term is minus 112. Okay, on simplifying this, I will take 4 on the LHS. So what do we get? 4 into S5 equals S10 minus S5 we get. So minus S5, taking that side, becomes plus S5. 4S5 plus S5 gives us 5S5 equals S10. Okay. Now we will use Sn formula to find out values of S5 and S10. What is Sn formula for an AP? N/2 into 2A plus N minus 1 into D. Okay, we don't know value of D, so we'll write D as it is. N value here will be 5 and A value we know it to be 2. Now substituting this, what happens to this equation? We get 5 into S5 is what? 5/2 into 2A. A is 2 plus N minus 1 or 5 minus 1 into D equals, what is the RHS S10? We are using the same formula Sn, okay, we get 10 by 2 into 2a, a value is 2 plus 10 minus 1 into d. Since we have to find out value of d, I have written d as d. Okay. Now, on further simplification, I can write this as 5 into 5 by 2. 2 2s are, what is 2 2s are 4, plus 5 minus 1 is 4 into d. Then on the RHS, what do we have? 10 by 2. I can simplify this to be 2 5s are 10. So it is 5 into 2 2s are 4 plus 10 minus 1 is 9 into d. Okay, I can cancel these two 5s. What are we left with? We are left with 5 by 2 into 4 plus 4 into d. What is left on the RHS? 4 plus 9d. Okay, now I will take this to that side. Okay, we have 5 into 4 plus 4d equals 2 into 4 plus 9d. Okay, multiplying 5 with this binomial on the LHS, what do we have? 5 4s are 20 plus 5 4s are 20d equals 4 2s are 8 plus 2 9s are 18d. Okay, our aim is to find out value of d. So I'll take 18d to the LHS, 20 I take it to the RHS. What do we have? 20d minus 18d equals 8 minus 20. Okay, 20d minus 18d, what do we get? We get 2d equals 8 minus 20, we get minus 12. So what is value of d from this? D value, we get it to be minus 6. So now we have got value of a, value of d. We have to just show that the 20th term or A20 is minus 112. We will do that now. So what is A20? How can I write this in the terms of A and D? Okay, it is A plus 20 minus 1 into D, right? So 20th term A20 is nothing but A plus 20 minus 1 into D, where A is the first term, D is the common difference. Substituting those two values here, what do we get? A is 2 plus 20 minus 1, I get it as 19. D value is minus 6. So what do we get? 2 minus, okay, 9 6 are 54, 6 1s are 6 plus 5, 11. I get 2 minus 114. 2 minus 114 is nothing but minus 112. So what have we proved? We have proved A20 equals minus 112. It is nothing but the 20th term of this AP is minus 112. So we'll continue with further problems in the next class. Thank you.